Assalamu alaikum everyone. I'm Fauza Farin Khan, ID 2321593. Today I will be discussing the concept of graph, which are fundamental structures used in various fields such as computer science, network design, and mathematical modeling. A graph is formally represented as a pair of uh, graph vertex and edges, where V represent V is the set of vertices and E is the set of edges that connect these vertices. In simpler terms, a graph consists of a collection of vertices and edges that form relationship between them. Graph basics. Let's start with some basic concepts in graph theory. Adjacent vertex. Two vertices are considered adjacent if there is an edge directly connecting them. Undirected graph. In an undirected graph, edges have no direction. That is, if there is an edge between vertex v1 and v2, you can traverse it in either direction. Connected graph. A graph is connected if there exists a path between every pair of vertices in the graph. Completed graph. A complete graph is one in which every vertex is connected to every other vertexes. This means that there are no isolated vertices. By connected graph, a graph is biconnected if after removing any single vertex, the graph remains connected. This ensures that no vertex is critical to the overall connectivity of the graph. Next, if we go to the path of walks and paths, trail, a walk in the graph where no edge is repeated. What is the path? A trail where no vertex is repeated. And what is a cycle? That is a non-empty trail where the starting and ending vertex are the same and creating a closed loop. Distance. The shortest path between two vertices measures by the number of edges in the path. Graph representation. Graph represented in several ways. Adjacency matrix. Adjacency list a vertex degrees. In graph theory, the degree of a vertex refers to the number of edges connected to it. Degree, the number of edges incident to a vertex. In undirected graphs, it is simply to the count of edges touching a vertex. In degree and out degree. In directed graph, each vertex has an in degree, the number of incoming edges, and an out degree, the number of outgoing edges. The total degree of a vertex is the sum of its in degree and out degree. Type of graphs. There are some different types of several types of simple graphs, which can be complete graphs, cycles, wheels, n cubes, bipartite graphs, and new graphs from old. Let's move on to the complete graph. In a complete graph, in every pair of vertices is connected the total number of edges, and each number has a degree of n minus 1 for n is greater than 4. Complete graphs are non-planar. If we move to the next graph, that is the cycle graph, a cycle graph consists vertex connected in a closed loop. Each vertex has a degree of 2. There are exactly n edges. Cycle graphs are always planar regardless of n. Next, if we will see a new graph that will be called wheel graph. A wheel graph consists of a central vertex connected to all vertices of a cycle graph. The central vertex has a degree of n minus 1 and each peripheral vertex has a degree of 3. Wheel graphs are always planar. Next, we have bipartite graph. A bipartite graph divides the vertex into two disjoint sets with edges only connecting vertex is from one set to another. This type of graph is widely used in applications like matchmaking and network flow problems. In conclusion, graphs are powerful tools in various fields and helping to model relationships. So, if you have any question or any requirement, you can make you can ask a question. Thank you.